Hello students, welcome to Numerical Methods and Integral Transform course. I am N. Praveen Kumar, working as a assistant professor of mathematics. So, in this lecture, we are going to be discussing about curve fitting. So, here the curve fitting is, so basically the concept of curve fitting in this course we are going to be discussing about. So, if some data is provided, so the x series values x0, x1, so on xn that respect to y values. These y values may be the functional values, may be the experimental values. So, in these values, based on these values, we are going to be estimate or construct or fit a curve. So, whatever the curve we are going to be have, it may be the linear, it may be the second degree, it may be the cubic, it may be exponential, it may be power. So, based on the requirement, we are going to be construct a curve that the concept is called curve fitting. So, in this course, we are going to be discuss about the four different kind of the curves we are going to be discuss. One is linear curve, or we can also call it as straight line. The second one we can call it as second degree curve or parabola. Second degree curve, or we are going to be discuss or call it as second degree curve. So, the third one we are going to be discuss exponential curve. The fourth one is power curve. So, in this we are going to be discuss to construct the four different kind of the curves. So, to constructing this curve, we are going to be use the method as, so method name is method of least squares. So, using the method of least squares, we are going to be construct these four kind of the curves. What is this method of least squares? The meaning of this method of least squares is, so sum of squares of deviations. Using of this concept, we are going to be derive the respect to normal equations. Whatever the curve you consider, for that curve we are going to be derive the normal equations. Using of the normal equations, we are going to be fit a curve. It may be the straight line, it may be second degree, it may be exponential curve. So, basically how we are going to be estimate is, there will be two kind of the values as I said. So, one is the functional values or observed values. So, observed values. Now, we find something expected values. Let us assume the observed values O1, O2, O3 something. So, this is O1. So, O1 is located something, O2, so O3, O4 observed values, where the expected values using of this fitting of this line. So, maybe you are getting nearer to this, maybe on the same line, maybe plus or maybe minus like this. So, if you are trying to be draw the observed line frequency or expected frequency, we are going to be according to that we are going to be draw this line. Look at the difference between these two. So, this difference we are going to be considered as sum of squares of deviation concept. Using of the sum of squares of deviation, we are going to be derive the normal equations of each particular method. Using of that normal equations, we are going to be evaluate that respect to constant and substitute back in that. So, the very first method we are going to be discussing in this lecture, straight line. So, there will be basically the straight line, the two kind of the things we are going to be consider. So, straight line, it is y on x. So, y on x is, you can just consider y is equal to a plus bx or y is equal to ax plus b. So any one of the consider based on the requirement. If it is mentioned, particularly we will be go for that particular curve. If it is not mentioned anything, then we are going to be consider any one of the curve. So it doesn't change much. So if you consider this, so here A coefficient becomes B here. So X coefficient B here, where in this curve this. So whatever the form you require, accordingly we are going to be consider that. So using of this least squares, method of least squares, we are going to be derive the normal equations. So let us assume the straight line, as I said, the two different curves. So just you consider whichever this related to the given question, accordingly we are going to be use that particular thing. Look at the question first. The temperature. So this is application of the straight line. So in the real time example, how we are going to be fit a straight line, using of this real time example we are going to be fit. So if you see the, as I said, using of method of least squares, we are going to be construct normal equations. If you see the normal equations of this curve, so simple remember is A coefficient is 1. So we need to be remember summation y Na plus b summation x, where so the second arbitrary constant is b, b coefficient is x. So therefore we need to be multiply with this, like that you need to be remember summation xy is equal to a summation x plus b summation x square. This is what the first one. Where the second one, so simple change, this second equation becomes the first, first equation becomes the second. Look at the second one I am writing here, y is equal to a x plus b. So a coefficient is x, obviously we need to be multiply with this. So summation xy is equal to a summation x. So x into x, x square, b summation x, where b coefficient is 1. So therefore obviously we are going to be get the second equation as summation y is equal to a summation x plus b summation x square. So this is the two different kind of the equations we are going to be write normal equations. These normal equations are very much important. Based on these normal equations, we are going to be find out these particular summations. Now look at the question now. So the temperature T, so temperature T in degree Celsius, length of that particular rod, heated rod. So length is given in mm, millimeter. So heated rod length are given below. If the line is given, L is equal to A naught plus A1T, find the best values of A naught and A1. So usually this application is where, so they have tested in the laboratory and providing, giving the some temperature to that particular rod. So if the temperature 20 degrees Celsius is given, the length of the rod is 800.3 mm. So if the temperature 30 degrees Celsius is given, so it is 800.4 degrees Celsius. Like this, they are giving some temperatures and length of the rods is recorded. So now if I fit a curve for this, if I find this A0 and A1, substitute in this, like let us assume. So L is equal to, you are substituting A0 value, so you are substituting A1 value, then T. So we are generalizing this curve. So later you are going to be substitute T is equal to any temperature, whether it is recorded one or 65, it is not there in that. So just you substitute T is equal to 65 degrees Celsius, automatically you will be get the length of the rod easily. When it is outside even this value, it may be 75, 85, you are going to be get the length of the rod easily. So each and every temperature we cannot able to record in the laboratory. Sometimes the laboratory may not be support more than 100 degrees Celsius. Then the time using of this provided data, just we are giving or putting that above 100 or 200 degrees Celsius temperature, we are going to be estimate the length of the rod easily. So now as I said, this is what the general notations I have used. This is first form and this is second form. If you observe this is, let us assume A0 is equal to A, A1 is B. So T is something X. So it is comes under A plus BX, this form. So this particular form. So therefore we are going to be use this particular normal equations. So whatever the notations is given, using of that particular notations, we are going to be write the normal equations. Look at the given straight line is, the given straight line L is equal to A0 plus A1T. So as I said, A naught quotient is 1. So therefore need to be apply the summation. Summation L is equal to A n A naught plus A1 summation T, where the A1 quotient is T. Obviously the second equation multiply with T and take the summation. So summation TL is equal to A naught summation T plus A1 summation T square. So these we can call it as normal equations. So using of these normal equations, now we require the summations. Summation L is required, summation T is required, summation TL required, summation T here, summation T square. So these values we are going to be find. For that we need to be construct a table. In a table, so like L value is given, T is given, so in the question itself, so T square we require, so TL we require. So we need to be find out that respective values and find that respective summations. These summations we are going to be substitute in this, then solve these equations. Obviously we are going to be get A naught value, A1 value, so that we are going to be do it back. That will be doing the next slide. So look at, so this is what the given data 20, 30, 40, 50, 60, 70. These are temperatures. The length of the rod is provided. This is what the given data 800.3, 800.4, 800.6, 800.9, 801. So where that equations I am going to be write one more time here. So summation L. So summation L n A naught plus A1 summation T. So summation. So second equation summation TL A naught. So A naught summation T plus A1 summation T square. So summation L is required. Sum of all these values, if you just type in the calculator, so summation L is required. So if you type in the calculator, you are going to get this value. That value is 4803.9. Now, so that I am going to be substitute in this. So 4803.9, which is equal to n. N is nothing but number of observations. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So 6 is the number of observations. 6 A naught plus A1. A1 that we need to be find, right, as it is. Summation T, where summation T sum of all the T values 270. That you need to be write 270. Look at the second equation. So TL is required. So each and every observation we need to be find. 220 into 800.3 is 16,006. So 30 into 800.4, 24,012. So 40 into 800.6, you are going to be get 32,024. Like this, each and every observation we are going to be get TL values. T, simply T into L, that result we are going to be get TL. So sum of all these TL, each and every observation, you are going to be get this value something. So whatever the value, it may be the biggest, it may be the smallest one, you are going to be substitute in this equation. So 216201. So this is done, summation TL is done. Now equal to A naught summation T already there, that we are going to be substitute 270 plus A1 summation T square. So where the summation T square is this, so therefore 13,900, so T square into A1. So now these are the two equations. You can use any one of the calculator, just type in the calculator, simplify, you are going to be get A naught value and A1 value. So if you substitute in the calculator, so A1 you are going to get 800 and A1 is 0.0146. So this is what A naught and A1. So what is actually the given curve? So the given curve is, so L is equal to A naught plus A1t. So therefore L is equal to A naught is 800 plus A1 is 0.0146 t. So this is the curve which we fit by the given data. Now we can substitute. T is equal to 90 degrees Celsius. So L is equal to 800 plus 0.014690. So therefore, that respect to length of the rod we are going to get, that is what the advantage of this particular so fitting of a straight line curve. So like it may be the general one, it may be other data like we are going to be get. So as I said, this is the two kind of the categories we have in the fitting of a straight line. One is y on x and other one is x on y. So in the y on x, as I said in this lecture, so we have y is equal to a plus bx or y is equal to ax plus b. The similar way, x on y also having two categories, x is equal to a plus by and x is equal to ay plus b. So these curves we need to be just write the normal equations. So these two I have just given the normal equations how we are going to be constructing this. Similar way, this is also we are going to be write. So summation x is equal to na b summation y. So summation xy is equal to a summation y plus b summation y square. So similar way, this is also comes under x on y. So therefore you will be get the equations in the same form. So summation xy is equal to a summation y square plus b summation y. So similar way, b quotient is 1. So therefore summation x is equal to a summation y plus nb. Like this we need to be construct the normal equations. Solve these normal equations. We are going to be get this a and b values. So that we are going to be substitute back. So therefore a value something and b value y. Now this complete process we can call it as fitting of a straight line. So this fitting of a straight line, we are going to be use the methodologies, method of least square concept, method of least squares concept. So in this lecture we clearly discussed about fitting of a straight line. So this any one of the curve which is mentioned will be go for that. If it is not mentioned, if it is y on x, you can consider any one of these. Similarly, it is x on y. So we consider any one of these. If it is mentioned particularly, will be go for that particular curve. So in this lecture we discussed about fitting of a straight line. So in the next lecture we are going to be discuss about fitting of a second degree curve, or you can also call it as parabola. So parabola or second degree curve, which is a similar concept, we will be discussing in the next session. Thank you.